Okay, as we continue on, this next section we're going to cover is sets. And sets is the very foundation of mathematics. If there was anything that you'd say all of math has in common, or all of math lies on, it would be the idea of sets. In fact, you might say that mathematics lies on a foundation of logic, and then from logic we have the idea of sets, and then from sets you get lots of other things. You get things called functions, which you may have heard about, and all sorts of other things as well. But really, all of mathematics lies right there, and it's material which is kind of foundational. Um, Back when I was in junior high school, we started studying sets, and the reason we did was because of what the Soviets did after World War II. Basically, during World War II, you probably know the United States developed the atomic bomb and used it twice to on the cities of Hiroshima and Nagasaki in Japan, and that brought the war to a close. And then after the war, it turned out that it was clear that the two kind of superpowers in the world, which were, even though they were together during the war, they soon became adversaries, and that is the United States and the Soviet Union, which is Russia together with all the satellite countries. And the United States had the lead. We had the atomic bomb, they didn't. But because of spies that they had in the United States, they soon got the atomic bomb, and then they also, soon after the United States, got the hydrogen bomb. So these two huge weapons of mass destruction were acquired by both of these countries. England and other countries ended up getting them too soon after. So anyway, it became a technical arms race, and it was kind of a question of who was going to have the superiority in all of the technical things that were going to be coming up after the World War II. And it was anyone's guess until suddenly the Soviet Union sent up the first rocket up into space. Sputnik, the name was. And that sent shock waves through basically the whole government and all the people concerned in the United States, that suddenly the Soviet Union was ahead. And it was decided that they were ahead, among other reasons, because they were just more developed in their mathematical knowledge. And so we decided to basically, we had to beef things up and teach at a higher level of math than we had been doing already in the primary grades. And so that started something called new math. And new math, which I learned in the 7th grade, but they teach it already, and they were teaching it in the 2nd and 3rd grade, all involves the idea of sets. So that's all to say that this idea, even though you may or may not have seen it, it's not anything especially hard. It's something that you can learn already in primary school. But for now, people aren't learning it so much in primary school, and so you might be seeing it for the first time right now. The other thing I'll say about sets is that, as I say, this is what was used to basically develop all of mathematics. And Bertrand Russell, one of the great philosophers and mathematicians of the 20th century, used logic to start developing the idea of sets, and it was only on page, it was somewhere in the 220s, maybe 232 or something like that, of the 2nd volume of the book of the set, did he finally get to the point, after starting with logic and going to sets, did he finally get to the point of proving that 1 plus 1 is equal to 2? Believe it or not. So if you really want to prove that 1 plus 1 is equal to 2, you can't do it by taking a penny in each hand. You do it by starting with logic and reading through Bertrand Russell's book. So anyway, there's a lot of interesting stuff here, both historical and mathematical, all involved in sets. So let's start learning about them together. So a set is just a collection of things. It's just a collection of things is all. And you just have to be very clear about what the collection is. So I'm going to let U stand for the set of all the letters in the English alphabet. A, B, C, all the way through X, Y, Z. So there are 26 things in there. In fact, one way we indicate that there's 26 things in there is we say that the cardinality, which is denoted by our author as just the number of things in U, is 26. It's just a way of counting them and saying how many things are in there. So there's 26 things are in there. It doesn't matter what the order is, as long as they have those things, that you can switch the order, it's still the same set. And so that's the set U. Any set like this where there's only a finite number of things where you can count them, that's called a finite set. If you have a set, for example, the natural numbers or the counting numbers are this set right here, which go on forever, that's an infinite set. So it is possible to have a set with an infinite number of elements. We'll talk about that a little bit later. But this would be a finite set. There's just 26 in there. As soon as you have a set, it's kind of nice to say, well, what's in it and what's not in it. So here's the terminology we have. For example, H is in there. So we might say H, and here's the terminology. H is an element of the set U. Okay, that little thing there means is an element of or is a member of. Okay, so that's what that means. To say that something is not in there, like alpha, for example, that's not in this set. So the way you'd write it, if you wanted to, would be say that is not a member of U. Okay. As soon as you have a set, I made U. I called this one U because I want to think of this one as my universal set. In fact, sometimes you just draw a big diagram over here to indicate what your whole set is. So there's the set U. This is called a Venn diagram. You don't need to learn all these words from me, but it's called a Venn diagram when you just draw a box with a bunch of circles in it to indicate your set. So there's all of U. Then if you want a particular subset of U, here's the way you indicate it. So let me explain what I mean. Suppose we want all the vowels. What are all the vowels in the alphabet? It's A, E, I, O, U, and I'll include Y in there as well. A lot of words use the Y as the vowel. And so that's a subset. That's a subset of U. I could kind of draw it like this and say there's the set V right there. So the things that are in there are A, E, I, O, and U. H would be out here, right? There would be H. I'd put a little dot there just to indicate H. So A, E, I, O, and U, they're all in there. Okay, that's that. This is just a lot of things to learn in here. If I want everything in my universal set, everything in here, which is not in this set, here's the notation for it. You put this set with a little tick mark. And that means everything that's in U, but not in here. Sometimes another way to write it is you say it's everything in U, but then you subtract, you get rid of everything that's in V. So if this is V right here, then all of this stuff right here would be V complement. That's called V complement, or the complement of V. Okay? So you've got that. What else do we have? Let's choose a couple other sets here. Let's let A be the set of A, B, C, this is capital A, D, E, F, G. I think we'll just go up to G. Yep. And then we'll let B be the set E, F, G, H, I, J. Okay? So there's the set A. Here's the set B. So they're also in here. Let's get rid of there for now. And so if I wanted to include them, I might say here's the set A right here. And here's the set B right there. Okay? So this is called a Venn diagram. And so now, once we have these various sets, we look and we say, hey, there are some things which are common to both of these sets. Notice that E, F, and G are in both of these. So the way you write that in set notation is you put an upside down U like that. A like that, B. This means intersection. That's the intersection. It's the intersection. So that's everything that's in both of them. So what's in both of these? As I said, I think it's just going to be E, F, and G. Do you agree? So that would be E, F, and G. That would be in both of them. And what about A intersect V? What are all the things that are both in A and V? I guess that would be what? Small a and small e. Agreed? That would be that. And what are all the things that are in B and V? See if you can stay ahead of me. B and V. Well, let's see. That would be what? E and I are the two things that are there. So like that. Okay. What are all the things that are in A and the complement of V? A and the complement of V. Well, let's see. To be in A means you're in here. To be in the complement of V means that you're in one of the consonants, right? You're not any of the vowels. So it'd be B, C, D, F, and G. B, C, D, F, and G. Right? See that? So let's do one more. What are all the things that are both in V and in V complement? Well, nothing, right? That's the whole point. V complement is all the things that aren't in there. So if I ask what are all the things that are in both V and what are all the vowels, is there something that's both a vowel and a consonant? There's not. These are the vowels. Everything other than that are the consonants. So I need some way to indicate that there's nothing in there. Here's one way of doing it. You just make a couple little braces like there with nothing in between. That's the way to indicate that there's a set with nothing in there. It's called the empty set. Empty set. But it's a little bit, I don't know, it just seems a little bit strange to have a couple of those braces with nothing in between. People might think you made a mistake and intended something to be in there. So another way to write it, which is a little bit easier, is to use the Greek letter phi. Okay, so there's the Greek letter phi, and that also just stands for the empty set. So whenever you're talking about sets and you see that, that's referring to the set with nothing in there. Okay? So you've got that. Okay? Are you with me yet? We're going through this, lots of stuff here. This is all in the book as well, of course. So those are all the things that are both in A and B. Okay? You use the word and. They're in both of them. Another thing you can do with two sets is say, hey, what are all the things that are in either A or B? So now we want the things that don't have to be in both of them. All you have to do is be in one or the other. Okay, so to be in A or B is to, let's see, let's list them out. So there's A, B, C, D, E, F, G. Okay, those are all the things in A. Now in B, well, there's no reason to write E, F, and G. Either something's in the set or it's not. There's no reason to put it in there twice. No reason to have your phone number in the phone book twice. once is enough. So E, F, G, what else is in B? It's either H, I, and J. So there's the union. That's called the union. That's called the union of A and B. Okay? So you've got that one. Let's do a couple more. What about the union of A and V? That would be what? A, B, C, D, E, F, G. And now we have the rest of the things that are in V as well. I've already got A, E, so I need I, O, U, and Y. I, O, U, and Y. So that would be the union of those two. Okay? Make sure you have a nice big union sign there. Okay? What would be the union of V with the complement of V? Well, that would be everything, wouldn't it? Because this is all the vowels and this is all the consonants. You put them together and you got everything. So I could list them all out, or I could just say U. Okay? Just say U. Okay? Just one other little piece of notation I need to give you, and then we're going to work with this a little bit more. We talked about being an element of a set. This whole collection V belongs to U. So you can write this. You can write V is a subset of U. That's because everything in V is also in U. Okay? So there are lots of subsets of U here. B is a subset of U because everything that's in B is also in U. Okay? I could make up something else. I could say the set with just H and O in it is a subset of U. Okay? Agreed? Or I could do this. I could say the set with E and I in it, that's a subset of V. Agreed? Because this is a set here. Everything in here is a vowel, so everything in here is in V. So you could say a subset. I could also say the set with just E in it is a subset of V. That's fine. Everything in this set is contained in V. Or I could write E is an element of V. See the difference between these two things? This is talking about a set. It's a set with just one thing in it, but it is a set. This is a set with one thing in it, and everything in this set is also in V. And here you're talking about just an element. This particular element is in V, so you can write that as well. Finally, if you wanted to, I'm running out of space here, I could say that the empty set is a subset. It's a subset of everything, because everything that's in here is also in V or in A. Let me just say this is a subset of A, because everything that's in there is also in A. Okay? I'm a single man, don't have any children. A lady across the street yesterday, it was just Father's Day on Sunday, and she said, did your children come home for Father's Day? And I didn't want to tell her all about the fact that I'm single with no children, so I just said, yes, all my children were here for the entire day, which is exactly right? Because I don't have any children at all, so all my children are here for the entire day. So that's kind of like what this is. It's saying that everything that's in here is also in here, and that's true because there's nothing in there. Okay?